So 70% of our freshwater resources on this planet now are used just for agriculture irrigation. And we're drawing down our freshwater resources all across the planet at an absolutely unsustainable rate.
Now this well is at least more than 150 years old, and we had a water level of 30 feet. That was just 40 years back, I'm saying, 30 feet, and now today the water level, the groundwater is 100 feet. So there's a drop of 70 feet.
In China, for example, where 80% of grain is dependent on irrigation, they're drawing down their groundwater, some places already pumping from 1,000 feet deep. Here in the United States, where the Ogallala Aquifer provides most of the irrigation water for the heartland, that's been drawn down by half since 1960.
In California, big impact, particularly in Southern California, but also in any arid region of the world where we irrigate, is salinization of the soil and applying a lot of water. The water evaporates and leaves behind salts.
The loss of productive agricultural soils due to salinization equals that now of losses due to erosion. And so this is why 10 million hectares of land are being abandoned annually in the world because of salinization.
So we use dripper lines. Dripper lines use vastly less water and less electricity to bring water to your field crops. We planted the lines of broccoli down the outside, and we planted tatsoi, a wonderful Asian green, down the middle. The benefit is, if you're looking at this bed from the top now, you actually can't see the soil, which means the sun isn't reaching the soil. So the soil is staying shaded, it's staying moist, reducing the weed competition, and therefore reducing our labor. It also reduces evaporation, so it means we can water less. We make about 200 to 300 yards of our own compost every year, entirely from materials here on the farm. And that goes into our fields, a couple inches thick in every bedrow. It helps maintain water moisture in the soil. We have friends and neighbors who are irrigating about 3 or 4 hours of drip per day, and we're doing about 1 hour of drip per week. That's the difference in terms of feeding your soil. That allows us to use 1/10 or 1/20 of the water that some of our neighbors are using in this exact same environment here in California, where we have a dry season, long dry season.
Here, what we see is soil from the Rodale Institute Farming Systems trial. We have 300 milliliters of water that is going to be introduced to 1,000 grams of soil. Here is the simulated rainfall. Okay, do you see that we're having runoff now? And this runoff is actually showing the erosion of the soil particles. And we're going to see somewhat different effect when we have organic soil related to the increased organic matter. Do you see that there is some runoff occurring, but the runoff is much clearer, and there's more water that is being absorbed into the soil. When we add compost to the organic soil, the loss is less than 100. When we have the mulch and the organic system and compost, there's more water that is being absorbed into the soil. Now you see how clear the water is here. As we improve the soil, we get much less runoff. One of the ways of avoiding catastrophic floods is by improving our soil. Now we're going to take these beakers out, and we're going to show you what's happening below the surface. If we look at the bottom of our containers, we see that actually there's no water that runs through the conventional soil, so that you're not getting anything that could be supplying the aquifers, the water storage that is underground, or the surface rivers because of the poor nature of the soil. But as we use these organic soil methods and we create an organic soil, what we see is that we're getting not only less water loss on the surface, but we're getting water charge in the subsurface, which is feeding our aquifers and our surface streams. So this is very good for our natural resources, and most of our water come from underground water sources.
So we've watched here at the Rodale Institute over the years is when we have drought years, our organic fields can produce 30 to 70% more corn or more soybeans because there's the organic matter in that soil than a conventional chemical synthetic-based farm ever could. So when they talk about what we need is bioengineered plants for drought resistance, we're kind of slapping our foreheads and going, what? What we need is healthy soil with organic matter in it, and you don't have to put a bioengineered gene into that plant. You can outproduce conventional by a whole bunch by just improving that soil.
Now here we have a new technique called organic no-till, and you can see that the soil is covered with a cover crop that is rolled down. When we put a mat on it, the materials that are in it are high in the nitrogen that is needed for the corn plant. We get both the fertility and better resource conservation.
In my gardens, I grow two things all the time. 50% for people, which is the potato in this case, and 50% of the land for nature, the soil improvement cycling crops. It's very important. Without a balance between the two, things will collapse. In my gardens and in the gardens of the future, I believe, we need to recognize and feed nature as we feed humanity. And so I grow this crop of mixed soil improvement plants. You can call them weeds. They're mustards and vetches and clovers and a wide range of different plants in here, and as well as potatoes. There are no bugs, there are no disorders of any kind out here. It all transpires. And the potato plant has not yet come to bloom, and it's an immature potato plant at this time of year, but we'll harvest one just to examine what it looks like. We see large masses of fibrous root systems, and we see nice, soft, crumbly soils that have good aggregation to them, held together by yeasts and molds and bacterial colonies filled with fibrous small root systems. And there's the mother potato, and it's just beginning to fruit, and it has a few small new potatoes. And it weighed about 2.5 or 3 ounces, and it's still solid. It has yet to be drained. It's just barely begun. Generally, under this circumstance, I will plant one potato in this garden, under the way I garden. I'll plant one potato and I will get 14 equal-sized potatoes. This is also part of nature. Humanly trained, I'm afraid. Well, that's the end of the potato story. In the U.S., there's 100 million head of cattle that are grazing the land, 7 million sheep, and 4 million horses. And the U.S. Department of Agriculture reports that we have a serious overgrazing problem. And of course, that contributes to increased soil erosion. Not as bad as Africa, where they've almost totally stripped all the grass off the land.
About 5 years ago, we certified our cattle as organic. And in doing so, we stopped any inputs, of course, to the soil and to the plants, but we also stopped using parasiticides or any antibiotics. And we were walking around, and I remember 2 or 3 years ago, we looked at some cow patties, and we noticed some holes in the cow patties. And I remember talking to my sister, Ginny, saying, do you remember when we were growing up, we'd see cow patties, and they'd be filled with holes, and then the cow patty would disappear. I said, they're back. Whatever's doing that, it's doing it again. The parasiticides that we give to the cows come out very concentrated in their manure. It ended up killing the natural dung beetle that was here. And it didn't kill them all. They just started to recover when we stopped using those parasiticides. With the dung beetles, they'll take little packets, and they make little balls, and they'll carry it up to 4 feet away from that dung pile. So what you're actually doing is spreading the fertility around, aerating the soil, and they're doing their job.
because the cow patty, if we don't have the dung beetle and they don't move, you end up with a burned hole in the grass from the high nitrogen content of the manure and the shading. And as it decomposes, that's where the increasers come. That's where we end up having thistles and weed problems. So, truth be known, we've actually had a reduction in weed problems after certifying organic. We've also had an increase in productivity because the soils are healthier, the microbes and the critters in the soil coming back to life. Properly managed grazing is the best thing that can happen to our California grasslands.
For millennia, animals have been part of agriculture, and that's because they're an important part of our diet, but also they're a unique way of breaking down organic matter, breaking down plants, and returning them to the soil in a way that feeds the microorganisms in the soil so that they can keep making those minerals in that cycle available to the next plants that are growing.
In traditional agriculture, animals were an integral part of the farm because they returned nutrients, especially nitrogen, into the soil in their manure. But as we moved into industrial agriculture and removed those animals, we created two problems. Large accumulations of manure, which means a lot of nitrogen in the wrong place, and soils that were depleted of their nutrients, so that we now have farmers who are dependent on synthetic fertilizer.
About half of the fertilizer that we add, half of the nitrogen fertilizer is lost from the system right away, and about half is taken up by the crop. And that's the average. It can be much higher. In vegetable systems, you can end up losing 80% of the nitrogen.
Small amounts of nitrogen are continuously brought into an ecosystem by bacteria, which fix the nitrogen from the air into a plant-available form. In organic farming, leguminous cover crops and manure add nitrogen to the soil. There is minimum leakage of nitrogen in these organic farming ecosystems because the nitrogen is released slowly, and most of it is taken up again by living organisms. When synthetic nitrogen fertilizer is introduced into the field, plants can use it to produce more biomass, and for a farmer this represents higher yield. But plants can only use a limited amount of that nitrogen fertilizer. So some farmers use more and more fertilizer to get smaller and smaller increases in yield. Excess nitrogen is released into the ecosystem, and forms of this nitrogen go into the air as potent greenhouse gases. Fertilizing nitrogen also leaks into the soil and into the water system, creating a range of problems from nitrates in drinking water to the eutrophication of waterways and ultimately dead zones in the ocean.
You end up with a lot of extra nutrients in those waters, and that causes algae to bloom, the plankton take off, then they die, they sink down to the bottom. And while they're decomposing, the oxygen demand goes up. So all of a sudden, where there was oxygen to support fish, shrimp, other shellfish, there isn't any, so they all die. Then you've got even more dead organic biomass to decompose. In the Gulf Dead Zone, the average size for the last few years has been about 7,000 square miles, about the size of the state of New Jersey. There is one dead zone, the one in the Black Sea, which was the largest dead zone in the world, that disappeared for about 10 years because when the Soviet Union collapsed, they could no longer afford fertilizers. So that's promising. It means that we can do something about it if we change our practices. The strategy that we need to use is to look at improving our field efficiency, and this has implication for greenhouse gases, including carbon dioxide production, because this synthetic nitrogen that we're using is extremely costly in terms of energy, which means it produces a lot of carbon dioxide. This accounts for about 50% of the energy use in agriculture. So if we're continuing to just use it at a 50% efficiency, we have the environmental consequences of the leakiness and also of the energy use and all the pollution that occurs from manufacturing it. One strategy that has a huge impact is to just modify rotation so that you have cover crops alternating with the cash crops. And we conducted a study of all the research that's been done looking at cover crops, and we found that on the average, if you introduce cover crops into an annual rotation like corn and soybeans, you reduce nitrate leaching by 70%. So that's a huge reduction.
A healthy soil is the fundamental part of a healthy grapevine. Of course, the fundamental of healthy soil is adding organic matter to the soil. So if we came out here in February or March, we would be up to our chest in peas, oats, vetches, cover crops that we've grown to add organic matter back to the soil, along with the compost that we make from our grape pumice. And here's a nice earthworm, and we can just see this is like chocolate cake, basically. And this just smells so good. This is going to provide all that this grapevine needs now to provide great grapes with deep flavor. Well, you know, we came out here and into another vineyard in the Napa Valley, but there's really something fundamentally different about this vineyard is that the soil itself really doesn't have a lot to contribute to this grapevine or to these eventual grapes. And the reason is they've not added organic matter back to the soil, and therefore, as you can see, it's become hard and compacted, so it's really become dirt, not soil.
We started this farm back in 1974. One of the things they told us was that we wouldn't really be able to farm organically in California because California is an arid climate. I mean, even here on the coast, we have a lot of rain. We have 30 inches of rain annually, but it all occurs in a matter of 4 months. So we have a long period of arid conditions, and we were told that probably you weren't going to be able to farm organically in any commercially successful way because you couldn't get the humus levels high enough to have the bacteria in the soil hold the nitrogen and the fertility elements that it needed for the crops. It hasn't been difficult. In the early years, we would do really what we're doing now. In the fall, we plant cover crops. In the spring, we plow those down and then start planting and put out compost. And in fact, we're farming organically all over the state now. And this farm is the oldest certified organic farm in California.
Once we changed and we started to compost our livestock manure and put that back on the soil, we used green manure cover crops and incorporated that biomass back into the soil. Within 3 years, and even our neighbors who would walk across the field saying, "Yeah, this soil is so spongy. Now, what did you do?" And it was that living, that return of the life of the soil. Within 2 to 3 years, you can make a tremendous difference in soil, honoring that law of return.
For 28 years, this area has received conventional agriculture. And one of the things that you'll see here is that the corn is actually spindly and yellow, and this is related to the soil has not improved during the experiment. This comes from long-term organic management. One of the things is that people would freak out with these weeds because they would say that they're taking away from the crop. But our long-term data shows that we can produce even more in these organic systems than in the conventional systems. So that, like a lot of this has to do with how you view things. Can you let life live?
One herbicide that was really touted was glyphosate. The trade name is Roundup. The testing that they did before the product came on the market was only on the active ingredient itself, not on the actual formulated product. Not only does glyphosate destroy mycorrhizae in the soil, they can actually decrease levels of beneficial soil microorganisms and increase the level of harmful ones. Over 95% of the soybeans in the U.S. are genetically engineered. What is that trait that is engineered into them? They're called Roundup Ready soybeans. They're designed to be used with Roundup.
So where we've gone in and destroyed the biology in the soil, we have to be putting on inorganic fertilizers. We have to use pesticides. We're going to have weeds. So it becomes this downward chemical cycle.
There's over 10,000 agrochemicals that have been registered for use in agricultural production systems. So what we have is a deadly cocktail that has developed.
Over 1.1 billion pounds of pesticides worth $25 billion are used each year, much of it ending up in soil and water.
U.S. companies have submitted applications to the EPA to get approval for corn that is engineered to be resistant to 2,4-D, which has been linked to non-Hodgkin's lymphoma. 2,4-D is an herbicide that was in Agent Orange.
Atrazine is an herbicide that is used to control weeds in crops. In the case of atrazine and nitrate, especially those two mixed together, nitrates shut off your defenses to your body against toxic chemicals, and so it's like tying your hands behind your back. We found that common lawn chemical mixtures at very low concentrations can induce abortions and resorptions of fetuses. This is something that was not expected, but the greatest interest here is that the greatest effects were at the lowest doses, not the highest doses. Fetuses are exquisitely sensitive to very small concentrations of chemicals. These chemicals can completely alter developmental trajectories. Abundance of nitrate and atrazine is associated with human birth defects, baby male genitalia problems, learning abilities in terms of math skills and in terms of language skills. Kids who are conceived in these months when these pesticide concentrations in water are high have higher probabilities of all these kinds of developmental problems and fertility problems.
Everything we are is made of the soil. The food we eat is a produce of the soil. If we have declared a war against the soil itself, if we ensure that the fertility through which the human species can continue is robbed from the soil, then we are literally committing a species-level suicide.
If this soil is healthy and balanced, this cabbage plant is going to be healthy and balanced. The corn plant will be healthy, so that when we eat the crops, we're going to be healthy.
And what I'm seeing with this farm, and by tending this farm, and the soil here is very, very healthy, you end up getting this whole food web.
how do the various species and organisms within the system interact with each other and benefit from each other? And how can you then in agriculture organize those in a way that you get those synergies, those benefits from the synergies? One of the really exciting things here is that we have this working relationship between the farmers and the chefs in the restaurant.
Well, there's something really special about working with passionate chefs.
To get that good carrot, you've got to have good ecology behind the carrot. It's grown in the right soil, it has the right amendments in the soil, it was picked at the right moment, all of these issues that improve your overall local ecology, because generally if that carrot's so delicious, it's locally grown.
Blue Hill Restaurant here is well recognized now, not only throughout the community, but throughout the country and even to some extent throughout the world, as that's where you're going to have the best meal of your life.
And as those meals go out, occasionally catch a taste and just see the presentation, what he's trying to get across, which is really just trying to get across this awareness of relation to the food.
I think the answers are on these little microbiological levels, literally, because it translates, for me, going back to flavor. And you cannot have good flavor without that kind of attention to detail and knowledge of the biology and knowledge of the chemistry, knowledge of these interactions that are going on a soil level that are key to health and to flavor.
And that to me is hugely inspiring.
The best economic returns are from the best vegetables and fruits and even meats that are grown in the right way.
So here we do not bring any outside inputs for either our livestock or our horticulture operations. Everything that's used here and all of the waste that's produced here gets composted and put back into the system.
Just like the carrot is not the carrot is not the carrot, compost is not compost, not compost. I thought if you make compost, you make compost, right? But there's a recipe to that that's as interesting and as profound and as important as the recipes that I'm making in the kitchen. And if you have the biology right, you're going to taste these different levels of flavor.
The success that we've had in our food system over the last 70 years or so has been due to a unique convergence of circumstances. One is this incredible supply of cheap energy in the form of oil and natural gas and coal.
We saw in the UK in the year 2000 when the lorry drivers went on strike and there were no lorries moving and there was no fuel, liquid fuels, we came about a day and a half away from a major food crisis in this country because it came very clear that we had no food resilience to fall back on.
So the real question is, what kind of food system are we going to transition to when we no longer have these cheap fossil fuels that provide the fertilizer and the equipment and everything else that's made these highly specialized productive systems possible? People think, well, it's not going to be such a big problem because there's alternative energy. So all we got to do is switch from Mideast oil to corn-based ethanol from Iowa, and then, problem solved.
Biofuels in the United States are being produced with corn. 99.9% are with corn. Corn production in the U.S. causes more soil erosion than any other crop grown in the nation, number one. Number two, corn production uses more nitrogen fertilizer than any other crop grown in the nation. And the leakage of the nitrogen goes down the Mississippi, and the National Academy of Sciences indicate that corn production is the prime cause of the dead zone down in the Gulf of Mexico. Another, corn production uses more insecticides, more herbicides than any other crop grown in the nation. Because it takes 40% more fossil energy to produce that gallon of ethanol, that means that there's significant contribution to the global warming or carbon dioxide because of the excess fossil energy used. Oh, I should mention the water. It takes 1,700 gallons of water to produce 1 gallon of ethanol.
A very inconvenient side effect that could happen from a very aggressive move towards biofuels is that if we grow the crops that would provide those fuels in ways that are as erosive as conventional agriculture is now for growing corn, say, we could be in a situation where we're essentially trading a system that mines oil for a system that mines soil, in which case we've just changed the time frame over which we're going to engineer a disaster.
We didn't ask the question, as we use more land and put pressure on more farmers to produce more corn, to both provide for the feed and for the fuel, and on top of that, the exports, where are we going to get the additional land from? We sort of kidded ourselves into believing that, well, we could just increase the yields rapidly enough so we don't have to worry about more land, and of course, that hasn't worked that way.
I think what happened in science, and I come from a science background, is we became too reductionistic and we started to look at things too narrowly. And what the healthy soil conversation is really about the whole biological system. And rarely do we investigate things as a system.
In 1984, there was a drought in the south, and lots of animals were dying, and there was migration. So I studied the region, and I found the rain hadn't reduced. So why was there a drought when the rain was the same? And it turned out that new seeds had been brought that reduced the plant height, got rid of the straw. There was no straw for the soil. There was no straw for the fodder for animals. So your rainfall was the same, but you had a soil drought because your organic matter had not returned. You had a fodder drought because you had now redesigned, in this case, the sorghum, to produce more grain for the market at the cost of less organic matter for the soil and for animals.
%60 of our ecological systems now are reaching the point of collapse. If that were to happen, then it will fundamentally change the functioning of the planet. Now, I don't know if everybody grasps the meaning of fundamentally changing the functions of the planet, but that really means that the planet could evolve into a kind of climate that's not very good for us as a human species. How do we continue to produce an adequate amount of food for a population of 6.5 billion people and getting larger? We have increasing energy costs, depleting water resources, and more unstable climates and more severe weather events. They have to be addressed in terms of fundamentally changing the way in which we produce our food, which makes it more resilient. And the only thing that I can see that really looks promising is to get back to the fundamentals of the soil.
We can sequester over 3 tons of carbon dioxide per acre with organic regenerative methods, whereas conventional chemical-based agriculture emits carbon dioxide.
So we would solve so many problems if we would just get the biology back into the soil, stop killing it.
When the colonialists came here in New England, this became a key area to produce food for the Burlington area. In the middle of the 20th century, we began to see the transformation of agriculture so that local food production began to move further and further away. Those farms essentially became difficult to stay in business as they competed with food from around the planet. And when we got here, which was 30 years ago, there was one farm left, the last dairy in Burlington, run by a 90-plus-year-old woman, and she was just hanging on. We started to take on the restoration of this floodplain, which had become really a dumping ground for the city of Burlington. And we saw this as just an exciting opportunity to imagine the transformation of the food system, which was what our business was about, producing local food in your garden. This is a floodplain, sandy soil
We had lost almost all the organic matter in the soil. So one of the things we could do is we could take all the waste from the community in terms of food waste and yard waste, and instead of taking it to dump, we could put it into a compost project. That compost has brought the fertility back up to 4 or 5% organic matter in the soil. That then gave us the capacity to incubate and create the farms that are down here now. 0.1% of the food eaten in Burlington was coming from Burlington, and we had a goal of could it become 10% of the fresh food. We're in Vermont, it's cold, so you can't do it all year, but we're getting awfully close to 10% of Burlington's fresh food that's consumed here now being produced here in the Intervale. There are now 13 farms down here. They share greenhouses, they share tractors, they share irrigation. They are now sharing refrigeration. They are sharing distribution, so we have a food hub that actually aggregates their available excess supply and gets it out efficiently into the community. We actually have about a dozen employers who have supported the idea of a CSA where we actually are distributing weekly to their employees. We deliver right to their places of employment. So the employers began to realize the value of local food, health, and connecting their employees to the local food system. This is not just happening in Vermont. It's happening all over the country. So we have people knocking on our door saying, could we do this in our community? The simplest answer is make sure you've got fertile soil, and if you don't, figure out how to get there and get it accessible so that it's not too expensive for people to farm. Make sure that you can support young people to be able to be successful at farming, and make sure that the market is there so that they can make a good living. You put those things together in a dynamic, interrelated way where policy plays a role, but ultimately it's the economic system that is that which is driving, I think, our future success. One of the things that works here, and in many old cities you have that same situation, is a forgotten bunch of land next to rivers that actually are fairly fertile and could be brought back to life. And sort of the integration of people to agriculture is a lot of what this new food system is about.
One seed you plant, you get 1,000. 1,000 seeds you plant, you get 1,000,000. Fertility really is the power of the soil to keep producing, the power of the seed to keep reproducing year after year after year.
It was called the IAASTD, the International Assessment for the Role of Agricultural Science, Knowledge, and Technology in Development. And it was basically, what's the answer for world agriculture? And after a 4-year process, in 2008, the final report came out, and they basically said that the answer is not high-tech, it's genetic engineering is not going to save agriculture, neither is nanotechnology or these high-tech solutions, but the answer is these more ecologically rational agroecology.
The question is, can organic, sustainable agroecology feed the world? Sure it can. And I know this because I was involved myself in a lot of research in Africa. We have quadrupled, up to even 10 times more yield, totally sustainable, organic actually, by doing the right thing and by building soil. So the yields go up year after year to reach levels which, if every African farmer, let's say, would produce according to some of those systems, there will be plenty of food around for everybody. But, there's a but here too, it doesn't fill the pockets of a few business people. This helps the farmer and the consumer. And we have to widen this stem to make sure that there's more connections from farm to consumer and also more people in between. It's important because agriculture needs input-output, no matter what you do.
Yeah, once a week we do a box of food. It's done. 6 to 10 pounds.
And you can imagine sort of two possible alternative futures. If we continue to aggressively pursue plow-based conventional agriculture the way that we are at present, we'll eventually deplete the supply of soil. Eventually, the areas of highly fertile, highly productive agricultural soils will become very valuable and fought over. They will become sort of the central organizing element of the geopolitical reality. Why? Well, because soil is the fundamental resource. On the other hand, agricultural techniques like intensive organic agriculture and no-till that can produce large crops of food without depleting the soil, and in many cases actually improving soil quality, it would encourage sort of small-scale, labor-intensive organic farms that would supply what's coming to be known as the local food movement. Two very different futures, both of them totally possible, and the mechanisms that may guide us towards one or the other are going to evolve from what consumers choose to do with their food dollars and what governments tend to encourage, subsidize, and or penalize or regulate. The future's wide open.
Back in the 1960s, the chemical companies tried to sell the idea that chemistry was better than life forces, and they called this better living through chemistry. But now through science, we understand that there's lots of side effects from the chemical approaches to food and agriculture. So we call this better living through biology.
When you go to this system, the soil returns to what it was like when it was first broken out. You know, you go out there and you start digging in that, and that's just an awesome thing, you know.
In the original Hebrew, Adam is the masculine form of the Hebrew word Adamah. Adamah is soil. So Adam literally means earthling, and as described in the 2nd chapter of Genesis, Adam is fashioned by God out of Adamah, out of the earth. The translation is the dust of the earth, but it's really the afar, the material of the soil. And now the question is Adam's mate, in Hebrew Hava, or in English rendered Eve. Hava means literally life or life giver. So together the combination of Adam and Eve mean quite literally soil and life, perceiving that life is associated with the soil. Adam and Eve are placed in the Garden of Eden, which means literally the Garden of Delight, which is nature, and given an assignment. Not mastery, but a role, a task, to serve and preserve. It says in Hebrew, le'ovda u'leshamra. The King James translation says to dress it and keep it. But my translation is to serve it and to preserve it. We banish ourselves from the Garden of Eden by despoiling it. And when mothers see their children playing in the soil now, they say, oh, that's dirty, and they rapidly, quickly wash their hands of the dirt. And we misapply that terrible word dirt to soil, which is the fount of all cleanliness, by the way.
Something in here.
Think of all the many generations of people in past generations who've died of all manner of disease, and somehow the soil cleanses them all and recycles their bodies into the materials of life.